Okay, this new lesson is going to start with exponential functions, and we're going to discuss the graphs of those exponential functions. Okay, so on the very first part here, when we talk about exponential functions, then we have a certain base that we'll start with, and most of these problems will have f of x equals, and it's going to be some base b raised to some exponent x. And so now notice that our x variable is going to be in the exponent. So looking over at our graphs, notice it tells us when a is greater than 1 and b is greater than 1, the function is increasing and called an exponential growth. So an example of that would be f of x equals 2 to the x power. Now a point that is always on this graph is going to be the point 0, 1. And that's because if we evaluate this function when x is 0, we're going to have 2 to the 0 power, which is always 1. So we have this function going through the y-intercept at 0, 1. And then we're going to have this because notice our 2 raised to the x power can never be equal to 0. So we're going to have our function run super close to the x-axis, but it's never actually going to be on the x-axis. So we have our exponential growth. Now the next part of this, when a is less than 1 and b is less than 1, then we have an exponential decay, and the function is decreasing. And a good example of this would be f of x equals 1 over 2, all raised to the x power. And once again, we will let x be 0, and then the entire fraction would go to 1. So we still have the same y-intercept of 0, 1. However, the function is now decreasing. And once again, this function can never be equal to 0, so it's going to look something like this. And we can plug in some points and do a t-chart, but all of the graphs will end up looking something like this. Now we will look at the graph of f of x equals 3 to the x power. And before we start graphing, it's a good idea to go through a t-chart just to see what our values would look like. So we're going to set up a good t-chart, and we're going to pick some different values here. So I'm just going to start at 3, and so I'm going to sub in that 3 for x, and so 3 to the third power is going to be 27. Then I'm going to select 2, and so 3 to the second power is 9. I'm going to choose 1. 3 to the first power is 3. And then we're going to go to 0, and we should have 1 there. And then we're going to look at the negatives. And so I'm going to have negative 1/3 for a point. Negative 2 is going to be 1 over 9. And negative 3 is going to be a very small number, 1 over 27. So notice all of these values here, they're approaching 0. And all of these values up through here, they are approaching infinity. They're growing without bound. So when we graph this, that's going to give us a pretty good idea of what's going on with our graph. So over here, we do have the point 0, 1. We have the point 1, 3. We have the point 2, 9. And then 327, I'm not going to bother with that. It's going to go off the graph. And then we also need to keep in mind at negative 1, we were at 1/3. And then at negative 2, we were at 1/9. And so notice we're getting closer and closer and closer to that x-axis. And when we connect these points, again, notice we're running up across the x-axis. We don't need that to cross the x-axis. So we do need it, though, to get as close to that x-axis as possible. We're just not ever going to cross it. So there's going to be the graph of our function. And so let's answer some questions about it. The first one, this would be a growth. Notice our graph is increasing from left to right. The domain, well, I could choose any x value and substitute in. However, my range, though, my y values, they're going to get as close to 0 as possible, but it's never going to be equal to 0, so we need to keep that open. And then we will tend toward positive infinity. Our y-intercept we saw was 0, 1. Our asymptote, that's going to really hinge up here on that range. It's going to be a horizontal asymptote, and it's going to be equal to 0 because we are getting as close to x being 0 as possible, but never really equal to it. Increasing interval is going to be from negative infinity to positive infinity. And so our decreasing interval, there's not going to be any. And our end behavior. So we know to set up our end behavior, x is going to approach negative infinity, and x has to approach positive infinity. As x is approaching negative infinity, our function itself is approaching 0. And then as we're approaching positive infinity, our function itself is also approaching infinity. Next example, we are going to look at 1/3 raised to the x power. And again, we're going to set up a t-chart just on these first few, just to make sure we understand where our values are coming from. So for the first part, we have x, and then we have our f of x. And again, let's start with the same values. Let's start with 3. And so whenever I plug in 3, that's going to be 1 to the third over 3 to the third, which is 1 over 27. 2 is going to be 1/9. 1, that's going to be 1/3. And again, 0, which is an important point for us, that's going to be a 1. -1, remember that means a negative exponent is reciprocal, so that's going to be 3. -2 is 9. And -3 is 27. So again, when we start graphing these, we notice that this function itself has really been reflected over the y-axis. So here, when we plot, we have 0, 1. And then we're going to go forward 1, 1/3. So again, notice it's getting smaller and smaller and smaller. We're getting closer and closer to that x-axis. But if we go back at -1, we're at +3. And at -2, we're all the way up here at 9. And so again, we're going to have that same basic shape. We have the same y-intercept. And again, we're going to get as close as we can to that x-axis, but not really ever equal to it. Now let's answer some questions. Would this be a growth or decay? We can look at this and tell it's going to be a decay. Our domain for this, again, we didn't have any restrictions on the x values we chose. Our range is still going to be super close to the x-axis all the way to positive infinity. Our y-intercept is still at 0, 1. Our asymptote is still the x-axis, which is y equals 0. Now this time, notice we have no intervals of increasing, but since this is a decay, we are decreasing from negative infinity to positive infinity. And finally, our end behavior, again, remember, you always have x approaching negative infinity and x approaching positive infinity. Now, as we move toward negative infinity, our function itself is moving toward positive infinity. And then as we approach positive infinity on the x, then we are approaching 0 over on the y side of things. Now, when we get to example 3, we see that doing a t-chart every time is not really in our best interest. It's really time consuming. All of these graphs will always maintain the same shape, and they should maintain the same y-intercept. So let's just look at our t-chart and let's plug in 0. And if x is 0, then 2/5 in parentheses, all raised to the 0 power is positive 1. So we know we have here 0, 1 once again. Now, this is where it's a good idea to look at our base number here, our 2/5, and notice that this fraction is less than 1. Notice 2/5 here, that is less than 1. So chances are this is probably going to be a decay, and that we know we can go back and look at if we need to, that base being less than 1. So notice our exponent as well, that is it can be positive or negative, but then our value in front of this is also positive, understood 1. So we have all of the things that we need in order to make a quick sketch of what this graph should look like. And again, since it is a decay, we know that it's going to look something like this and get super close to that x-axis. And that's going to be all we need to draw this. Now, as far as answering our questions, growth or decay, we've already noticed that because we had to graph it. So this is a decay. Our domain, once again, should be all real numbers. Our range should be from 0 not included to positive infinity. Our y-intercept, once again, was the same. And our asymptote here, y equals 0. Increasing intervals, again, this should be none because this was a decay, decreasing from negative infinity to positive infinity. And once again, our end behavior, x is going to approach negative infinity. And then we also need x to approach positive infinity. And looking at this, as x approaches negative infinity, f of x is going to approach positive infinity. And then over here, f of x is going to approach 0. Right, in example 4, again, we're not going to spend time doing that t-chart. We do know, however, that if we have x to be 0, then we know that our function itself is going to be 1. So we're going to go ahead and put in our y-intercept, 0, 1. We also notice that our base value, this 4, that is greater than 1. So as x values increase, so will the value of our function increase. So here we know that this is going to be an exponential growth. And so we can go ahead and just sketch what we know this to look like. There's not too many more ways to make that look any different. So here, when we go back through, we are going to go ahead and answer these questions. So for the first one, is this a growth or a decay? This should be growth. Again, domain and range are going to be the same again. So domain is going to be all real numbers. The range is going to be super close to 0, but not ever touching it to positive infinity. Our y-intercept was at 0, 1. Our asymptote is going to be horizontal at y equals 0. Increasing from negative infinity to positive infinity, decreasing none, and then again our end behavior. Again, x must approach positive and negative infinity. That's your x-axis. So as x approaches negative infinity, your function itself is approaching 0. And positive infinity, your function is approaching positive infinity as well. Now we'll talk about the natural base e, and that's something that we need to learn about. E is just like pi in terms of just being a constant value. let's go ahead and talk about our exponential function. F of x equals e to the x. And a lot of people are probably wondering what the heck is e. Well, let's go ahead and describe it over here. And this is very important for you to remember. E is an irrational number. And let's see, what else can we talk about with it? It's an irrational number with an approximate value of 2.718828459045, and so on. Now, this never repeats, other than you see that small little area where it started to repeat, but it doesn't do that consistently. Exponential functions with a base e are natural base exponentials, and we're going to be using that quite a bit. So if we're going to go through and graph here e to the x, which is an important graph for you to remember, keep in mind that e to the x is still this number 2.71828 and so forth. It's still a positive number bigger than 1, so this is still going to be a growth, exponential growth. Our domain is still going to be the same. Our range values, they're still the same. Our Y-intercept is still the same. Asymptote, yep, still the same. Are we increasing or decreasing? Well, if it's growth, we are increasing from negative infinity to positive infinity. Decreasing, there would be none. And even our end behavior is still going to be the same. We still look from positive infinity and negative infinity. And our function here from negative infinity is approaching 0. And from positive infinity, we are approaching positive infinity. So we see all these different characteristics, and it's going to look, when we graph this, identical to all the other stuff that we've been graphing. So here, a lot of times people see that constant value of e and they start freaking out, but it's really the same exact thing that we have been talking about. Now, with our graphs, we do need to talk about all of the different transformations. And again, we've talked about these before, but it's so important for us to keep in mind what all of this stuff is doing, which way does it translate, what kind of reflections. Remember, outside is over the x, inside is over the y. And then here, if A is on the outside, vertical compression, inside horizontal stretch, or compression again. So be careful with all of these. Let's go through and see if we can't answer some questions about it. All right, so let's list out the parent function, and then we're going to go through and discuss what kind of transformations are going on. So for this first one here, the parent function is going to be f of x equals 2 raised to the x power. And then our transformations, we're going to go left 1, and then we'll also move down 3. And again, left 1 because that 1 is up there inside the exponent, so that's going to be included inside parentheses, kind of similar to what you're used to seeing. All right, so let's talk about number 2. A part here, the parent function is going to be 1/2 raised to the x power. Now let's talk about those transformations. So for the first part, notice the negative on the outside. We are going to reflect over the x-axis, again because it's on the outside. And then let's see, we need to go right 5. And finally, we'll move up 1. All right, so looking at number 3, very similar to the same thing. Number 3, again, let's pick out that parent function. And so our parent function here, f of x equals 4 raised to the x power. And then the b part, talking about all of our different transformations. Notice here for number 3, we've got a vertical, we're on the outside here, so a vertical stretch. And since it is vertical, it's going to do exactly what it says, vertical stretch of 3. We are going to reflect over the x-axis because of the negative. We are also going to move right 2, and then down 7. Okay, for our next problem, again, very similar. Our parent function here is going to be f of x equals e raised to the x power, and then all of our different transformations. So let's see, we've got a negative on the inside. Notice that x is negative, so we're going to reflect over the y-axis. That's one part. Let's see, now let's address that 4/3 out front. That's larger than 1 and it's on the outside, so this is going to be a vertical stretch, 4/3. And then it looks like we're going to move up 5. That should take care of all of those. All right, and continuing right along with this, we are going to go through all of those transformations again. A, the parent function here, is going to be 2 to the x power. And then B, we're going to go through all of those different transformations. So let's start with the 5. So it's on the outside, so vertical stretch of 5. And let's see, then we will reflect over, because the negative's up in the exponent, so we need to reflect over the y-axis. Then we will translate here, we're going to go right 4, and then down 9. All right, so moving on to number 6. Again, this one here, it looks like it's going to be strange, but it's really a little more straightforward than you would think. Your parent function here is just going to be 2/3 raised to the x power, so that's not too bad. And then our reflections, again, you know that the negative is on the outside of this. So of that negative being on the outside, we're going to reflect over the x-axis. And then notice that 4 being up in the exponent. So that's going to be where we see our horizontal. And since it is horizontal and 4 is going to be a horizontal compression or shrink, because horizontal does different, it's the opposite of what we think, and it's a horizontal compression by, and it's the reciprocal, so it's going to be 1/4. Okay, so moving on to number 7. Again, the parent function here is e to the x. And then part B, all of our different reflections and such. So the negative on the outside, we know we're going to reflect over the x-axis. We have a 1/2 up here on the inside, so we know that's going to be a horizontal. And again, it's going to be the opposite of what we think. TCH, I can't spell stretch anymore. Horizontal stretch by 2. It's going to be by that reciprocal. And let's see, what else do we have going for us? Then we're going to be moving up 4. Okay, and one more to go through. For this one, again, your parent function here, f of x is going to be 3/4 raised to the x power. That's your parent function. And then B, going through all of our different translations, we know the negative on the outside, that's going to be reflecting over the x-axis. We have a 3 up here, so that's going to be a horizontal. Compression by 1/3, the reciprocal. And then it looks like we are going to move left 2 and then down 1. All right, now we're going to put to use all of those different transformations. So let's go ahead and write out once again what those transformations would be. So for here, we know that the parent function for this would be 3 raised to the x power. And just a real quick sketch here, we know that's an exponential growth. It's going to look something like this. Going to go through the point 0, 1. And that's the point we probably want to focus on to help in our transformation. Now, all of our transformations in part B, we know we are going to have to move right 1, and then we're going to have to move down 4. So over here on our graph, let's start at the point 0, 1. And I'm going to take that point and I'm going to move it right 1, and then I'm going to move it down 4. So there's where that point's at now. And so we now know that here this is going to cross a little bit differently. We know that this is a growth. And so when we do our sketch for this, then we've got to figure out, well, what happened here? Notice all the way down here at -4. Now, earlier we had a horizontal asymptote for our originals, and that was at y = 0. But now I've moved all the way down to -4, so now the new horizontal asymptote is going to be at y = -4 because it's been moved down 4. So let's go down 1, 2, 3, 4, and let's go ahead and sketch that because that's going to help us see where we need to cut off this graph at. Okay. And so with this being a growth, we know that we have our basic shape, but instead of it running super close to the x-axis, this time it's going to run super close to y = -4. And so we're going to have something that looks something like this. My pen said no right through there. All right. So there's what our new graph is going to look like. And so we need to come over here and talk about, well, what are some new points that I have? Well, the first one here, our domain, well, that's not anything different. That was all real numbers here. Now, our range, we saw, well, that's going to be running close to that horizontal asymptote. So we're going to say that that's going to be from -4 all the way up to infinity, and now -4 cannot be included all the way up to infinity. Now for our y-intercept, well, the y-intercept, let's see if we can figure out maybe where that's going to end up at. So to find the y-intercept, if we remember, we're going to let x be 0. So if x is 0, let's see what we get here. And it's probably going to be some ugly fraction, so don't freak out. We can use our calculators here if we need to for that. So if we let x be 0, we're going to have 3 to the 0 minus 1, and then minus 4. So that's going to end up being 1/3 minus 4. Well, 4 is 12 over 3. So that's going to be a -11 over 3. That's going to be our y-intercept, which is going to be about 3 2/3, which is about where we're at on our graph. And what else do we need to see? Our asymptote, we found that. That's going to be at y = -4. And our intervals of increasing, that's going to be, since this is an exponential growth, it's going to be from -infinity to +infinity. And then decreasing is going to be none. And our end behavior, as x approaches negative infinity, and let's talk about x approaching positive infinity. So as x approaches negative infinity, f of x is approaching not 0 anymore. Be careful. It's approaching that asymptote of negative 4. And as f of x is approaching positive infinity, or x approaching positive infinity, f of x is also approaching positive infinity. Okay, this problem, we're going to work it out just like we did with the other. We'll start by identifying what that parent function should be, and that's going to be f of x equals 1/2 raised to the x power. And just a quick little sketch here, we know that's going to be an exponential decay, and we also know that that's going to be the important point 0, 1. Let's go ahead and talk about our transformations now. This negative on the outside, so we know we are going to have to reflect over the x-axis. And then after we do that reflection over the x-axis, we also need to move up too. So we've got a couple of things that we're going to have to look at here. Now, if we take the basic shape, and again, I'm just doing a sketch here of the original. So if I take that original and then I reflect it over the x-axis, well then that reflection is going to make it look more like this. So do keep that in mind if you reflect over this x-axis. That's what's going on with this. Now we also need to do our point. Let's take that point 0, 1 and do some reflections with it. And keep in mind here, if we go through and we let x be 0, keep in mind there, if we plug in 0, well then we have all of that 1/2. Let's write it out. I don't want to do too much here in our heads looking at it. We'll get lost. Here, 1/2 raised to the 0 power, that is 1, but this negative out here is going to make that negative 1. So really, here, negative 1 plus 2, we have the 0.10 or 0, 1 again, which is strange with this, but that can happen. So that point is going to stay 0, 1. Now the next thing we need to look at would be also flipping over. Notice that we're going to have that same basic shape again. And let's see if we can figure out maybe our x-intercept, but that might be a little much. Let's just see if we can though. We're going to let f of x equal 0. And if we do that, we have negative and we have 1/2 raised to the x plus 2. So we're going to have negative 2 equals negative, and then 1/2 raised to the x. Well, those negatives are going to cancel each other out. So 2 equals 1/2 raised to what power? That's going to have to be negative 1. We're going to have to flip that back over. So our x-intercept, even though it wasn't asked for it, we could figure out that it's going to be negative 1, 0, which is going to be kind of useful for us. All right, so we have a couple of good points here. Now we do need to keep in mind that from our 0, our horizontal asymptote earlier was at 0, but now this has been flipped over and moved up to, so that really is going to tell me that at positive 2 is where that new asymptote is going to lie. So there's our boundary for the top. And I think we have everything we need to go through and do a pretty good little sketch of this. It's going to look something like this. And now we can answer those questions. So our domain, again, that domain can be any number. And our range this time looking at it is going to be from negative infinity up to positive 2, but again, not included. Our Y-intercept, we found that to still be 0, 1. Our asymptote is at y equals 2. Increasing interval, now this function is increasing, so it's changed on us a bit. It's tempting to say this is a exponential decay, but with that negative, that's doing all of our flipping for us. So now we're increasing from negative infinity to positive infinity. Decreasing, we have none. And then our end behavior. So we have to be careful with that. Again, your x's are always approaching negative infinity and positive infinity. And as x approaches negative infinity, f of x is also approaching negative infinity. As x approaches positive infinity, f of x itself is approaching that positive, or that asymptote of positive 2. Okay, continuing on, similar manner, we do need to talk about the original. What would be the parent function here? And that's going to be 1 over 4 raised to the x power. And again, let's do a quick sketch of what that should look like. So we see this is going to give us an exponential decay. We know that good old 0, 1 Y-intercept here. Okay, so we have that. Now let's talk about our different transformations. So here, that 3 on the outside, that's going to be a vertical stretch. And that's going to be by 3. So vertically, this thing is going to stretch out 3. What else do we need to do with this? The 5 up here, so that means we need to move this left 5, doesn't it? So we're going to move left 5. All right, so that's about all the information it gave us. Let's talk about our x and y intercepts. So keep in mind, if we do a t-chart here, and we can do that, we're going to take turns with that being 0 for sure. So if x is 0, let's plug in. And so we're going to have 3 times 1/4 raised to the 5th power. Oh, sweet goodness. So that's going to be 3 times 4 to the 5th, I think is 1024. Now, I don't have a calculator in front of me, but I know that's a freakishly small number, 3 over 1024. So we know that's getting super, super small. And so let's see, that's going to intersect then at 0. X is 0. Y is that? It is just barely above 0, 0. It's not quite 0, but it is so dang close. All right, so now let's let f of x be 0. So then that's going to say 0 equals 3 times 1/4 raised to the x plus 5. We're going to divide both sides by 3. And notice with this 0 equals 1/4, it doesn't matter what I plug in for x, this entire base is never going to change to be a 0. So that's not going to exist. And that looks like that's probably going to be an asymptote for us. All right, so based on what we see here, we know we've got to cross at 0 and 3 over 1024. We have a decay, and we're stretched out by 3. So, my goodness, I'm going to start way over here since it's a stretch. It's going to go through there, and it's just going to run as close to the x-axis as possible. All right, so let's talk about the domain. Again, domain, that's got to be all real numbers. The range looks like it's going to be from 0 to positive infinity. The Y-intercept, again, we found it. It was a really strange number, 0, and then 3 over 1024. Our asymptote, again, that's still, since we didn't add or subtract any value, we didn't move that vertically, then we still have an asymptote of y equals 0. Increasing, this function would not be increasing. It is decreasing from negative infinity to positive infinity. And then finally, our end behavior here. That end behavior is going to be, as we're looking at this from negative infinity, x approaches from negative infinity, and then x approaches from positive infinity. From the negative infinity, our function is heading toward positive infinity. And for positive infinity, the function is heading toward 0. In the next example, we are looking at the parent function of e to the x, and keep in mind this is an exponential growth. So the model is going to look something like this. We have here, that's going to be our y-intercept at 0, 1. Now looking at our transformations, the first thing that we have is that negative x, so we are going to reflect over the y-axis. So in other words, we're going to take this function and we're going to spin it around that y-axis now. And then we are going to move up 3. So starting at 0, 1, we do move up 3. So that's going to change also our asymptotes as well. Well, if we're already at 0, 1 and we move up 3, now we're at 0, 4. Also, our original asymptote was at 0, 0, or running through the line y equals 0, but now it's going to be moved up to run through 3 since we moved up 3. So we do have here, it's going to be our y equals 3. That's going to be our horizontal asymptote. Now let's go ahead. Nothing else has really changed other than it's flipped around the y-axis. So that's going to make this look a little bit different, not a tremendous amount. So again, we're going to come through here and we're going to run right parallel with that y equals 3. And there's going to be basically the graph of this, or just a good sketch of it. Here, domain, again, it's going to be all real numbers. We've been doing that funky R. The range, well, that's going to be from 3 to positive infinity. The y-intercept, well, that's going to be at 0, 3. Asymptote, y equals, that's going to be at 0, 4. Sorry, folks. The asymptotes at y equals 3. Increasing interval is going to be none. Since we're flipped around, we now have decreasing from negative infinity to positive infinity. And now we also have our in behavior. X is approaching negative infinity. X approaches positive infinity. As x approaches negative infinity, f of x is approaching positive infinity. And on the bottom, as x is approaching positive infinity, f of x is approaching 3. Since the video is running a little bit long, we're going to go over these last 2 videos in class to get us started before we do our homework.